Okay, this video is for Ishi, and we're going to go over how to solve that logarithm problem in this video. The question about with the matrices we'll do in another video. So I've got a whiteboard up here where I've already put the whole solution on the whiteboard, but we'll talk through it. Kind of looks like we're all jumbled around, but I'll point out what's happening. So here was the original problem. 2 to the 2x plus 3 equals 2 to the x plus 1 plus 3. We're supposed to be able to get an answer for x in the form a plus log of b base 2. So that's important as we reach the end of the solution to understand that we're supposed to use logarithms base 2 in our final answer. And the key to this kind of problem is understanding that this whole thing can be written as a quadratic equation, which can be solved by factoring. And it's not that easy to see unless you've had some experience with it. And your book actually does have an example of this, although it doesn't leave the answer in the form requested by this problem. I think it's on like page 237 or something. I don't remember. But anyway, the key is that we're going to use the properties of exponents. Here we have two expressions being added together, so I can break them apart into the product of two powers with the same base of 2. So I can rewrite this thing as 2 cubed times 2 to the 2x. And while I'm at it, I'm going to take this term, both of these terms, to the left side of the equal sign. And I'm going to break apart the 2 to the x plus 1 and 2 to the first times 2 to the x. And you can see if you multiplied those together, you'd add the exponents. And I'll also brought the negative 3 across. And now I'm going to rewrite 2 cubed as 8, 2 to the 2x as 2 to the x, the quantity, squared. Power of a power, I would multiply the exponents, so you could rewrite this like this. This will be minus 2 times 2 to the x minus 3 equals 0. And now the key is realizing that this is actually a quadratic equation in 2 to the x. So over here, let's skip over to here. I'm going to let 2 to the x in this equation be represented by the letter m, just so it's easier to see how you solve the quadratic equation. You don't have to do it this way, but it's, I think, easier to see. So I'm going to rewrite this, but I'm going to replace the power 2 to the x by the letter m. So I'll get 8m squared minus 2m minus 3 equals 0. You can solve this quadratic by factoring, it turns out, or you could use the quadratic formula to solve for n. And most of my students who have problems factoring trinomials, especially when this first letter is not a 1, haven't heard of the box method. So I thought I'd just go over that just in case you haven't heard of it, Ishi. Here in the general quadratic equation, ax squared plus bx plus c equals 0, to use what's called the box method, we're going to consider the multiples of a times c. So in our case, that would be 8 times negative 3. A times c equals negative 24. The multiples of 24 are 24 times 1. 2 goes into 24, so 12 times 2. 3 goes into 24 8 times, so 8 and 3 are multiples. And 4 goes into 24 6 times, and it's here that I realize I'm looking for two multiples that will have a difference of negative 2. The numbers that I'm considering have to have different signs because I want them to multiply together to give me a negative 24. And so since the signs are different, I want the resulting product to have a difference of negative 2. So I see right here, if I put the negative 6 and a plus 4, That's what I'm searching for. So the box method says put the 8m squared in the upper left-hand corner, put the constant term minus 3 in the lower right-hand corner, and then fill in these two boxes using these numbers. So it doesn't matter which place you put them, but a negative 6m I'll put in this one, and a plus 4m I'll put in this one. And then the key is to find out what the two binomials are. What you do is factor out the greatest common factor from each row. Really, this is just factoring by grouping. So you may have heard of that technique too, but a lot of students find it easier to do the box method. So I can factor out a 2m from each term in the first row, so I write that outside. On this one, there is no common factor other than a 1, and I'm going to use the sign from the multiple, the plus sign. So I put 2m plus 1. And then up above, I'm going to get the greatest common factor of the first column, which is 4m. And for the second column, I'm going to use the sign that I garnered from the multiple and factor out a negative 3. And lo and behold, there are my two binomials, 4m minus 3 and 2m plus 1, just staring us in the face after you've factored out the greatest common factors. Really what you're doing in essence is factoring by grouping. It's kind of hidden. And you can check by FOIL to see that the product of these two binomials does give you this. Setting each factor equal to 0, you get m equals 3/4 or m equals negative 1/2. Those two numbers make this quadratic equation true. But now I'm back to realizing that m is really 2 to the x power. So I'm going to replace this m with 2 to the x. 2 to the x equals 3/4, or 2 to the x equals negative 1/2. But there's no exponent that you can supply for x that's going to produce a negative number. Doesn't matter what you do, you cannot get a negative number. So this equation, exponential equation, has no solution. So now I'm down to solving this one for x. And you can take the logarithm of both sides. You could use natural logarithm, ln. You can use a common logarithm, base 10. But the problem said that we wanted our final answer to have a logarithm base 2. So I'm going to take the logarithm base 2 of both sides. And then on the left side, I'm going to use that property of logarithms that I can pull this x out front and get x times the log of 2 base 2. And over here, I'm going to use the log of a quotient as the difference of the logs. So this can be rewritten as log 3 base 2 minus log 4 base 2. Finally, the log of 2 base 2 is just 1, because 2 to the first produces 2. So there's an understood 1 right here. And over here, log 3 base 2 doesn't simplify, but the logarithm of 4 base 2 is 2, because 2 squared produces 4. So there's your answer right there. Log 3 base 2 minus 2, or minus 2 plus the log of 3 base 2. Now, I haven't bothered trying to check this answer in the original equation. That might be fun. But for now, I'm going to leave this video with this solution, and hope you understood what I went over. And later, look for the video on the matrix. Let me know if you have any questions on this.